Welcome to Summarize Science, where today we are looking at a breakthrough in how self-driving cars understand motion. One of the hardest things for an autonomous vehicle to do is predict the 3D movement of every object around it, a task known as SynFlow estimation. To do this well, AI usually needs thousands of hours of real-world data that has been meticulously labeled by humans, which is both expensive and rare. The researchers behind a project called SynFlow decided to take a different approach by training AI entirely within a simulator. They used the Carla simulator to create a data generation pipeline that produces massive amounts of high-quality, perfectly labeled 3D motion data. This allowed them to scale up the training volume significantly without the noise and errors found in real-world sensor data. Unlike previous attempts that tried to make simulations look photorealistic, SynFlow focuses on motion-oriented realism. This means the simulator prioritizes complex physics and diverse traffic patterns over how pretty the trees or buildings look. The resulting dataset, called SynFlow 4K, contains nearly 1 million frames of data, making it 34 times larger than existing real-world benchmarks. The system generates these scenarios by forcing the simulator to explore various road structures, like highway loops and complex junctions. They also programmed aggressive driving behaviors and dense traffic to ensure the AI learns how to handle difficult, non-linear movements. To test if this virtual training actually works, they compared it against the best real-world models on datasets like new scenes and truck scenes. By training on various splits of 1,000 to 4,000 sequences, they could see exactly how much the AI improved as more data was added. The goal was to see if a model trained on game data could generalize to the messy reality of actual city streets. The results were impressive, showing that the AI trained on SynFlow data could understand real-world motion without any prior exposure to it. In this zero-shot regime, their synthetic-only model even outperformed state-of-the-art methods trained on real data by over 30% on certain benchmarks. This suggests that the rules of motion learned in the simulator are highly transferable to the real world. Looking at the performance across different categories, they found that vehicles were the easiest for the AI to understand because they follow predictable physics. Pedestrians remain more challenging due to their non-rigid and often unpredictable movement, even in a simulated environment. One of the most important findings was how label-efficient this method is for developers. By using the SynFlow model as a foundation and fine-tuning it with just 5% of real-world labels, they surpassed models trained on the full real-world budget. This could save companies millions of dollars in data annotation costs, while actually improving the safety of the vehicle. The visualization here shows the variety of environments the AI mastered, from busy city intersections to merging on high-speed highways. By seeing these diverse kinematic patterns in 3D, the AI builds a robust motion prior that it can use anywhere. In conclusion, SynFlow proves that we don't need perfect visual replicas of the real world to teach AI how things move. By focusing on the complexity of interactions and scaling up simulation, the researchers have bridged a major gap in 3D perception. In the future, this could lead to autonomous systems that are much better at handling rare or long-tail events that are rarely captured in real-world logs. Thanks for watching Summarize Science, and stay tuned for more breakthroughs in the world of AI and robotics.